All right. Um, First thing, I'm not going to talk about Firefox OS. So, how many of you, let me gauge this, I have some trouble gauging the audience for this talk, so who has done some reactive programming before? All right, some hands. This is awesome because I'm going to give an introduction, and if you would have, all of you, just raise your hands, I have nothing to say. So let's start. This is going to be a short talk to get you excited about FRP, functional reactive programming. So I won't show crazy examples, but I'll try to show you the advantages and the reason why this is coming up lately. So who am I and what am I doing in your stage? I'm Sergi Mansilla. At my work, I work on Firefox OS. Before I worked at, that's my Twitter and GitHub, by the way. Before I worked at TomTom, doing HTML5 interfaces for the TomTom devices. And in Cloud9 IDE, maybe you know it, it's an IDE focused on many languages but has special cool stuff for JavaScript. Right now I'm working at Telenor, which is a telco you probably know because they're pretty big in Sweden. But all I do is work with the Mozilla team on Firefox OS. So they kind of lend me to Mozilla to work on that. Now, I'm very sorry about the shameless link baiting of the title of the talk. Like the fours they mentioned sounds pretty impressive, like I'm going to talk about space-time or something amazingly revolutionary. I'm just going to talk about programming. But, you know, the previous title I had was much worse than that, and I decided to change it in the last minute. So I'm pretty happy with the final result. All right, so I spoke about link baiting. Now, the fourth I mentioned actually is time. And as human beings, we are really used to deal with time. We can predict some events, we have a notion of the amount of time that is passing right now, we have calendars, when we are bored, we know that we've spent too much time doing nothing or something that we don't like. So time is a part of our lives. Developers have also hardwired time in their brain, but in a slightly different way. This is more what developers are concerned about. Whenever we program, we always keep in mind the fact that we're writing to disk, so we expect some delay, the fact that we're reading from memory RAM, or that we are pinging the network, that's the one that takes more time. So we're used to deal with this kind of stuff. And then there's JavaScript developers that have hardwired async in their brain in a completely messed up way. So we not only have the problems that developers have, but we also have the little quirky details about dealing with time in JavaScript. Thanks to its very nature, right? JavaScript has only one thread, and everything is asynchronous. If something is not asynchronous, it will block, and we don't want that in any application. So we're used to this kind of words. First it was callbacks, then promises came, now generators, but they're all events. So whenever we talk about an event, we don't talk only about the JavaScript events, click, and this kind of stuff that we're used to, but also when a callback comes back, when a promise executes its then method, that's an event that happens in our code. So one of the greatest things in JavaScript is that it's an evented language. One of the worst things is that it is an evented language. We use events to deal with all our synchronous tasks. We don't have much else either. So you're very used to this kind of code. This normal add event listener on the click event. And what this does is just if clicks is less than 10. So basically it logs all the clicks that happen on the right side of the screen. Until it reaches 10. When it has counted 10 clicks and has logged their coordinates, it stopped. So the first thing, this is a very simple task. the first thing you see when you look at this code is a lot of lines. Even for experienced developers, when you throw this code in their face, it will take them some time to see like, oh, okay, I see what he's doing. Because it's not completely obvious that we're just logging clicks on the right side of the screen. So why are we still micromanaging this kind of code, especially? What is happening here? What is happening here, or the important part of this code, what we're interested in is if clicks is smaller than 10, just log the coordinate of where the click happened. Sorry, if clicks is less than 10, and if clicks are happening on the right side of the screen, sorry, log the coordinates of that click. That's all we want. These are 3 lines out of 10. Why all the other lines? Why the unregistering the event? Why all this stuff? Because we never asked about it. We never used anything else. And this is very easy. You don't need any external libraries. Of course, it's for this example, you don't have to use anything else. That's as easy as it comes. But it's already kind of complex for what it does. What if we add constraints to this? Let's say that I only want to log this click event when I have the A key pressed. This is how it looks now with vanilla JavaScript. If you have another way to do it, just tell me. But what we have to do is add 2 event listeners, one listening for key down, and the other one for key up. We need another variable is A pressed that we initialize to false, and then on every key down event, we check if the key press is A, and in that case, we change the is A pressed to true. And on key up, we unregister the event. This is to add this little constraint of pressing a key. So the code is already considerably bigger, and if I hadn't explained anything of this to you, and I show you this code, you will take like a good minute to, at least a minute to understand what's going on, what am I doing there. And this is because we are still coding the how instead of the what. What we're doing is telling the computer exactly what to do. Like on this step, do this, and now store this in this variable so I later can come back at it and can see what, you know, if it's true or false and this kind of stuff. Instead of telling the computer, just log all the clicks on the right side, or just log all the first 10 clicks on the right side. Programming should be more about the what. What lady agrees. And that what programming the what is in programming world is called the declarative way of programming, declarative programming. So we should be able to declare what we want to do instead of instructing what to do. It is kind of delegating work. You know, it's an art. Knowing when to delegate work instead of doing it yourself, it's an art, because ideally, in the ideal delegation case, you just say what you want to be done to a person you trust that will do a good job with it, and you don't care about how it's done, right? You just want that person to go do the task and come back with you with the task done. It's like, you know, this baby, make it look like an accident. I don't care how it's happening. I don't care what it's gonna be, but just make it happen. Now, the problem with this, besides the amount of code that you see on screen, there's like might be a bother, but you might be thinking like, okay, that's not that bad. Some of the problems we have with that is the nature of that kind of programming. The main one, or one of the main problems, is the void callbacks. In the evented callback style of programming, which we use all the time, whether you use DOM events or you use Node.js callbacks, is that callbacks don't return any value. And if you return the value, it doesn't matter because nobody's going to use that value at any point. Callbacks just compose functions or just return call other functions, right? So the whole contract of programming, which functions do a task and return a result of this task, is broken. What happens when returns don't matter is that you have no other way but to do side effects, to have side effects. A callback, by its very own nature, provokes side effects because its return value is not used. So a callback always has to modify an external variable, print something, has to do something with an external value. It cannot keep everything inside, right? So in our case, this is the state we're adding inside simple code. We have the clicks variable and the isApress variable that we're modifying the whole time. But we don't care about these variables. We just use them to control our code. These variables are not part of the final delivery, what you want to do, right? And this is only with this small code. The thing is, we're used to this kind of programming, and we keep adding these little things. And in a small project, perhaps it doesn't matter that much, but as projects become bigger and bigger, you keep adding this kind of stuff. Another variable to keep that state, another variable to keep that variable, to remember this, to remember that are not really part of the problem. And you know, there's one day that there's one variable too much. And when you want to add a new feature, things break. And you don't know why. And then you have to start debugging this kind of stuff. Or even worse, you're not the one debugging it, but it's the next programmer after you, or a junior developer, or whoever comes after you, and then he looks at this code and sees something like that. It becomes really complex. So we know that state is dangerous, right? The problem is that many times you can only see that state is dangerous when you have a big application, and then it's too late. Now, there's another thing that I call, you know, actually, let me tell you about this callback stuff. When I criticize callback, sometimes people say like, oh yeah, I know what you mean. You mean the callback hell, the pyramids of doom, and I don't completely. I like callbacks. I like callbacks. They're very practical. They're very fast, very intuitive, very easy to use for small tasks. And actually, the whole pyramid thing, the whole thing that the callback hell becomes this unwieldy code, is not that much of a problem for me as much as they force you to use external state. There's also the event limbo or callback limbo as well. This is David Hasselhoff. He's singing in a limbo record. I found that amazing. So if you take something away from this talk, it should be that this record exists. That's the most important. So basically, the poor events, or callbacks in that case, what happens is that everything in JavaScript is kind of, you can treat them as a scalar or an object, but you can always store things in a variable, right, and operate with it and do stuff like with it, but not with callback functions. Once you let an event go, or once you start a chain of callbacks, off they go. You don't have a handle in it. You don't have any way to grab a handle of this on this callback and say like, oh, I want to cancel now, or I want to see the state of the callback, or actually let me retry this callback because it seems like I didn't receive any results. No, you just send it away and hope it comes back, maybe with an error, maybe with the result, but you cannot have a handle on it. So we have this. We have other problems. There's the awkward error handling, which everybody has found about it. If you code Node style, we're very used to this construct that Node does, passing the error first, and that's fine. But then the whole try-catch mechanism is pretty useless. But sometimes it's useful if you're coding front-end JavaScript, but sometimes it's not. It's kind of a bit awkward. It's fine if you are used to that scenario, but it is not very normal. It's easy to have memory leaks. You forget to unsubscribe an event. You probably will have a memory leak. And it makes every application much more complex than what it is. To the point that it's very frustrating if you're not used to that kind of programming or developing big apps. So, isn't that, in a way, the problem that promises try to solve? Kind of, but promises, as much as I like them and as cool as they are, fall a bit short for some scenarios, and I'm going to explain that. Promises provide a handler your asynchronous events. But they're good for solving asynchronous operations, such as querying a service with an XML HTTP request, where the expected value is one single value, or the expected result is one single value and then completion. They're not made for continuous events that keep coming. And now we're not very used to think about continuous events. What does that mean? But for example, in this picture, I showed what would the equivalent: the synchronous part on the left, promises on the right, and down below you have the synchronous part on the left and the reactive on the right. So in the first one, promises are dealing with a function that comes back and calls the then method with the value that got from wherever, maybe an AJAX call, maybe a user input. Down, we have some stock information. In the left, we have, if we had the stocks variable with containing stocks in an array, and we go through it with filter and map, and then in the end we can iterate over it. But that would be an array. That is not asynchronous. Now the reactive part would allow us to do exactly what we're doing with an array, but with values that are not determined yet, that don't exist. They haven't happened. So imagine it like this. Another example would be the user clicks of a mouse. So when a user clicks and clicks again and clicks after a while, or maybe clicks very, very quickly, all these are events. If we imagine them like this, you can see that this is a stream of events. This is an array of events in a way, but the events haven't happened yet. The events might be infinite. For all you know, the user can always be clicking, and the events they might happen one now, another tomorrow, but it's a sequence, right? So this is very important, because what is good, what techniques are good to manipulate sequences? That's usually functional programming. Functional programming is very good at manipulating a sequence, taking it as an input, and then having another sequence changed, or a value, or whatever, as an output. There's always input and output. So we use that all the time in JavaScript, in fact, with non-async programming. This probably looks very familiar to you, just an array of numbers from 1 to 10. You filter them, find the ones that are divisible by 2, map them, and put the word item in front, and then you iterate them, and you log them in the console. So we get the final values. We do that all the time. This is exactly what I'm talking about. We're manipulating a sequence. In every step of this, in every filter, every map, we generate a new array with the new values. We don't modify the initial one. So functional reactive programming does exactly that, but with asynchronous values, with non-known values. If you look for functional reactive programming in Wikipedia or FRP, which you will see everywhere there's this topic, the first result that appears is final resting place. Very depressing. The other one is fantasy role-playing. So people were very, very confused when I spoke about FRP usually, so now I say the whole thing, which is very, very long. So functional reactive programming. I'm going to show you something that I find very intuitive to understand how it works. Everybody here has used a spreadsheet, right? So what happens in a spreadsheet? In Excel or whatever spreadsheet software you use, you don't have to tell the program how to calculate values. You just go to a cell, write a value, another cell, another value, and another cell, and you say, like, I want the addition of these 2 values in this cell. Always. Just doesn't matter. Just do it, right? You don't tell the program, like, when that cell changes, update this result as well, and this result as well, and that one. That will get messy pretty quickly. But yet, that's what we do all the time in programming. We painstakingly tell the program exactly what to do to make the result, to produce the result that we want. Sometimes that's justified, but most of the times with the programming we do, most of the time is not. So, in short, reactive programming just deals with values that change over time. So it deals with values that don't exist yet, that that will exist, but they don't yet. And now, what I use for programming that way is all right. Do I have to go on without electricity now? At least we have light. Do you have a technician? Oh shit, I might have run out of batteries. Can I have an adapter? Anybody with, with an electricity adapter? Anyway, so while I wait for the adapter, I'll continue. The library I'm using for this, thank you, sir, is Rx.js. Rx.js is this JavaScript library actually developed by Microsoft by the Department of Open Technologies. Yeah, it will take a while. It was really discharged. So Microsoft has created this library, this reactive library, in the open source department that they have somewhere. You know, every now and then they surprise everybody by releasing something open source, and everyone is like, "Oh, wait, but would you do that?" But it's very good. And in fact, what they have managed to do is not only develop a library for JavaScript, but they have developed a library for most platforms out there. So you have the same APIs, the same kind of stuff for the same exact library, same APIs, same everything for JavaScript, Java, Ruby, C, Python, all the languages. So you can use the same paradigm of programming streams in all the environments you want, including PHP and stuff like this. I don't know how they did it, but it's pretty good. Other examples of this is, man, that doesn't turn on. Other examples of reactive programming in JavaScript, that's not the only one. Many people use Bacon.js. Is there the Bacon.js author here? Oh, okay. I will feel really bad. It is, you must like Bacon.js. Okay. Good for you. It is a great library. It is a great library. It's just not as ubiquitous as Rx.js, but really good. Same thing. If you use that, you'll be happy as well. Then there's Elm, the Elm language, which is a whole new language that compiles to JavaScript, but is based on reactive programming. And it's pretty cool. It's basically you can doesn't have mutability, and you can modify the entire state of your page and show new stuff like you would do, like show new forms or animate whatever. But because it has no mutability, it can, for example, store the whole session or the whole program, what it's doing. So you can go back in time at any previous state of your program because of this way of programming, because you're programming sequences that are not mutable. Yay, we're getting there. And that's Elm. You should check it out, elm-lang.com. Sorry, I have to log in, even if it looks like I'm not doing anything. And now things will open. That took a while. I'm sorry about that. So yeah, give me some seconds because everything is in that screen, not on my screen, of course. Oh man, everything is opening. Have you ever had this situation? Like all the software in the world is opening right now. Oh yeah, go ahead. Browsers. Sorry, I'm very dumb. You know, I cannot speak and do things in the computer at the same time. Does it happen to you as well? It's very hard. Okay, there we go. There we go. Let me mirror displays. Nothing shows up in the big screen though. Yay! That's actually not the current presentation, but another one. But thanks anyway. There we go. Yay! We got there. I'm sorry. Oh no, that's the last slide. No. Okay. And here we are. Yay! Okay. So I was in this slide. You almost didn't notice the thing. Okay, so that's our XJS, that's the logo. I spoke about Bacon.js Elm. This presentation will be somewhere, and you have to check it out. But I have 4 minutes and 50 seconds, so I have to go slightly faster with all this time I wasted. Now, when I talk about these technologies, many people will think, like, okay, another hipster technology I have to learn because some developer has found out some paradigm that has existed forever and now they want to apply it in JavaScript. And this is kind of what it is, but this method of programming is here to stay. It's happening everywhere. The reactive manifesto is a thing that some very smart people came up with that applies to many languages like Scala, new ways to program, so there's less mutability, etc. So RxJS, this library I'm using from Microsoft, helps us compose asynchronous programs in a declarative way. And the key in that is the declarative way. The example I showed you before about right-clicking the screen 10 times, what it basically does, all this code, what the purpose it serves is, say, like limit to 10, filter by coordinate, only on the right side, and then print the coordinates. That's all we want. That's how we would declare it. And that's how you would do it in RxJS. You say, from event click, you filter by this reason, take 10 of these elements, whatever it is, subscribe to it, and then print the coordinates. So yeah. Create an observable. I will talk about what an observable is in a second. Create a filtered observable from the first one. Create a final observable taking only the first 10 results, and then actually kick off computation. So until we don't call subscribe, nothing happens. We're just composing observables that will be executed when we subscribe to it. So what an observable is very simple. You know, an iterator is an object that you can call its next method. You say next, 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 and every time you call next, it shows you the next value in the sequence that is representing. And when there's no more values, it tells you like, no, it's depleted. There's nothing else. And an observer pattern, most of you know it, is a pattern in which there's an object to which you subscribe or listeners subscribe, and whenever this object has new results, calls the listeners and tell them. So it pushes the elements to the listeners instead of the listeners having to request. These are exactly... The funny thing is that nobody ever... These two patterns are very useful, but nobody ever thought of making the same pattern with these two concepts. Like instead of having to wait, instead of telling the object to give me the next value, the object just calls you with the next value. And at the same time, it has an error and an incomplete. So you know when things have gone wrong, you know when things have completed. With this simple concept, you can do crazy stuff. So for example, this is a range from 1 to 5. You subscribe to it, and you declare what function will execute on next, what function will execute on error, and what function will execute on completed. And then when you subscribe, it kicks it up and just enumerates the numbers, and then it tells you, okay, it's completed. This is not async, but you can still do that. You can compose, you create an observable, you subscribe to this observable, you can subscribe to the observable, to another observable, you can merge them, you can do all kinds of stuff. So every observable is immutable, and it will keep producing the same values, but you can compose new ones from operating on it. The most important thing for me, which is concurrency, is that it allows us to control the chaos that asynchronous programming is by just in a very easy way. In this example, I did it just before coming up to before having lunch. I take one source that is an earthquake, a real-time feed of earthquakes in JSON, which is the European one. I take the US or a US source of earthquakes as well. And if you see, in an interval of 5 seconds, every 5 seconds I merge both of the sequences. Does it work now? I merge the sequences, I extract the array of features, and at the same time, I take this array and make these values just be delivered one by one. And then you see the distinct method. By just calling the distinct and a function on what property to evaluate, I make sure that no repeated values come into my string. So just like that. So just like that, I have two sources, asynchronous sources. Oh, and the best one is that the first method, there's this retry method. It will keep retrying the source until it retrieves the data. So if it fails, it will try again, and it will try again, and whenever it's ready, it will come. But I don't have to worry about that. Whenever it's ready, we'll have the sequence, and I can operate on it. It's very powerful. That's how it looks. I can show it live if you want later. So yeah, I'm over time. Can I go 1 minute over? I just need 1 minute more and I'll be golden. Okay, so this one is pretty cool. Searching Wikipedia. You see the most important is at the bottom. At the top I just say how to search. I just tell it how to search Wikipedia. At the bottom we have from an event key up on an input field. I extract the value with map. I use where to say like when the text is longer than 2 characters. I throttle to 200 milliseconds, so if the user types very fast or whatever, I'll wait. Every 200 milliseconds I use what is in the input field, but to not bombard the server with a lot of requests. And in the end I say like treat the values as equal. So if the user doesn't change the input, imagine that I just move the cursor keys and I don't change the text, I won't keep requesting the server. So just give me really different values. These are one-liners. These are all, the whole asynchronous process is very easy to handle. And then in the end, when the key app observer yields all these values, I just filter them and always take the latest. This switch latest operator guarantees that I always take the latest value in time that came, so that an old value doesn't come before the new or stuff like this. Like concurrency is taken care of most of the time. It's very powerful and very easy to operate, and it lets you focus on the actual problem that you're tackling, not in, okay, how can I do this? How can I cancel the ones that are old if I have a new value that came back? This is very complex, and you don't, it's not part of your problem. This is how this works. This is a little bit more on that. And now, the last thing is that by encapsulating with observables, you can just get rid of for testing purposes, you can just substitute the one that you use normally by a mockup. The whole first search Wikipedia method is just a mockup, but it doesn't matter because it yields values anyway. So the observable doesn't need to know when it's really asynchronous or when it's not. Anyway, you can convert from all kinds of JavaScript values, arrays, callbacks, events, everything is prepared, so you can integrate in existing code base. You don't have to switch to the religion of reactive. You just can try with this, a little bit of code here, a little bit of code there. I don't have time for that. I'm probably not for that. It's also very fast. It doesn't loop every time. So just come see me, since I ran out of time. Come see me and I can talk to you more about it. I love this picture. So I'll leave it there for a second while I drink water. All right, this is used at GitHub, Netflix, Microsoft, and SoundCloud, and many more companies. So it's a very mature technology. It's not something that some guy is doing in a basement, and it's in the 0.1 version. It's really solid, really good. It has all this first-class asynchronous compatibility, concurrency encapsulation, Michael Hasselhoff sings Limbo. And I'm writing a book about this, so follow me on Twitter and you'll know when it's published, and I'll have more than half an hour to tell you about it. Thank you very much.